Welcome, everybody. My name is Frank Meerkötter. I work for basysKom, and today I would like to have a look at Qt and the web and where are we today. A bit of context. For me, it's a really strange topic, Qt and the web. I'm very much a Qt guy, C++, Qt, that's my thing. And how do I end up with Qt and the web? And the context is, also, basysKom is a very Qt-focused company. We are doing web projects from time to time, but we are very much focused on using Qt in all kinds of technical applications. That's our thing. Our typical customer is a machine manufacturer, device manufacturer from the DACH region. Rule of thumb, there's always some kind of machine attached to the projects we are doing. And how do I end up with Qt and the web? And this is basically what I would like to talk about today. Because the web has left quite a bit of impression in the last 25 years. So there is, for example, there is an embedded device we have developed, and the test team of the customer insists on using their web-based, Node.js-focused testing framework they already have. So how can I make this happen? Or there's an industrial control system pulling orders from an SAP or somewhere else using an HttP API. There is, or an all-time favorite of mine, the development team is already committed on using Qt, but the product management would also need something in the browser. Can you make this happen? So this is basically how I end up with Qt and the web. One step back. So the web is now around 30 years in its origins with us, and it was quite a success. It's omnipresent. Even my mom knows about, at least in rough terms, what a web browser is, and she has not a technical background. So it has left quite some footprint in the tech world, and it also, with this strong success, had quite a bit of influence on how things are done. Protocols are often clear text protocol, text-based protocols, stateless services, hypertext. This is all stuff that has left its mark. And for a lot of use cases, the web is a default. basysKom back in the day, for example, was also doing quite a bit of these classic between 2000 and 2010, migrating applications in the public sector, for example, to cross-platform, which was supposed to mean Qt, but actually it all migrated. All these database front ends, they all migrated into the web as cross-platform. So for a lot of applications, the web is the default today. So is the web also the holy grail of software development? Depends on whom you ask. But there are also, and keep in mind, I'm biased. I work for a Qt company, but it's a more or less strongly fragmented ecosystem. It's not the web technology, but it's a jungle of technologies you can pick your things from. And yes, jQuery isn't going anywhere, so that's always there. But if you're using a framework that has a little bit more abstraction, there's a lot of churn. Things are fashion-driven. What I always see is that there's less respect for APIs you have once developed compared to Qt, where you can live with certain APIs for a decade, perhaps, if things go well. And of course, if you have embedded hardware as your target, there's also limiting factors there. To integrate a browser engine is work on the system integration side. It tends to be fragile. And also there are performance issues. If you want to do your HMI with web technology, you might need stronger hardware. So might not be the holy grail, but still the web is very strong. And so this means, so even in 2019, there are good reasons to develop native applications if you take into account all these things that are a bit problematic. But such a native framework has to prove itself in a web world. And in the rest of the talk, I want to take Qt and look at it from 4 sides, basically. I want to see Qt as a client, so consuming data, Qt as a server, providing services for something web-based, web-focused. These are both API topics. And after that, I want to do HMI topics. This is on one side rendering web content with Qt, and switch around, that's the all-time favorite, getting Qt into the browser somehow. These are the 4 topics I want to have a look at. So Qt as a client. The use case is I need to interface a web-focused service. Might be that I need to pull order data from somewhere. Might be that I have to upload log files, result files, something like this. Or more complex, I need to interact with the REST API or WebSocket API. Well, for that I need an HTTP client. And there are also some things to consider on the side. Things like serialization and deserialization of data on these API. Transport security, I mean, it's 2019, we should think about transport security. And related authentication, authorization is also a topic. Might be not the ideal solution to just hard code the username, password in each and every client. So this is basically the problem. And what Qt has to offer to solve this, no surprise there, the Qt Network Access Manager has been with us since 2003, 2004, something like this. Even though it has an abstract name, it implements mostly an HTTP client. If you come from a different environment, which has a bit more modern async story, an environment with promises, for example, might feel a bit dated if you really have to do a lot of web work with the Qt Network Access Manager, but still get things done. This is the C++ side. On the QML side, you have the XML HTTP request API implemented on the JavaScript engine of the QML engine. This is basically analog to the browser API plus minus you find in the web browser. And this can be used to pull data or to send data into your Qt HMI without writing C++. If this is a valid use case, really depends on how your application is structured. And both of them support SSL or TLS via OpenSSL, the abstraction that's available in Qt. That was HTTP. We, since a decade or so, we have also WebSockets. WebSockets are basically solving the problem that classic HTTP was just request response. And for a lot of applications where a server wanted to push something into the client, you had to make use of all kinds of tricks, long polling, comet, stuff like this. WebSocket is the nowadays official way to do it. So every time something pops up in your web HMI, this is probably coming out of a WebSocket. Qt is supporting this not through the core networking module, but through the WebSocket module. Provides a client API for C++ and QML. So again, you can use it from both sides, and also supports secure WebSocket connections. This is basically the core client story. On the serialization, deserialization side, you have JSON support and XML support. JSON is most probably the more important thing nowadays, as it's a very popular format for a lot of REST APIs, web APIs. That's also directly supported in the Qt core, so you don't need any special modules for that. The only thing you won't find there is schema validation for JSON, so no JSON schema support. Would be a nice addition. On the other side, there are a few nice GitHub projects where you can pull in a schema validator that works with the JSON support in Qt. On the other side, there's XML, which might be a bit old school, but for a lot of enterprise and industrial applications, you still encounter a lot of XML there. You have a number of options in Qt, and these are options with different style and with a different abstraction level. There's a QXML stream reader writer directly in Qt core. There's a Qt DOM document in Qt XML, and there's a Qt XML patterns for the heavyweight XML stuff. So doing schema validations, doing XPath, things like this. Keep in mind the Qt XML patterns is a deprecated module, if I have this right. So, and we learned today, Qt 5 is nearing its switch over to Qt 6. So might not be the best case to start something new with Qt XML patterns. On the authentication authorization side, you often have the scenario that clients need to authenticate itself against services. And in the ideal case, you don't put a username and password into each client. There are various ways to do token-based authentication authorization. Qt is supporting some of these through the Q network authorization module, which implements OAuth 1 and 2, or a subset of that. So this has you covered on that side. This is basically scenarios where Qt is acting as a client. I've skipped over a number of scenarios. I come back in my wrap up because, well, I have 25 minutes. Qt as a server is the other. It's basically the other way around. The task on the table is to provide a REST or WebSocket API. Examples for that could be test automation. This is something we had in a project where an embedded device needed to provide a REST API for the testing teams. We also had projects where people are using headless Qt, so no HMI there. They are just using Qt as a friendly C++. That's a political topic, I know, but people are doing this, so it's interesting. For this case, the embedded device needed to provide a REST API and also some need to render pages and serve a single page application. It's also an integration point with other APIs. Certain connectors of ERP and MES software expect to find REST endpoints they can talk to. All this kind of stuff. And there was for a long time no QHttpServer. That was a dearly missed component. It's kind of still missing. There are a number of GitHub projects implementing a Qt HTTP server, but to my knowledge, none of them has gained critical mass. So if the person, I don't know, finished college or got kids or other hobbies, it basically fell in despair. So that was really something missing from the Qt ecosystem. The good thing is the Qt company started something last year. There was a number of blog posts, and also they talked to a lot of people what they needed, wanted to have. The result is unfortunately only a labs project, so nothing officially committed, but it's there. I did some air quotes around the official take by the Qt company, so they are very happy getting feedback on this. It would be nice if it could mature to a real module within Qt, because it's, at least from what we are seeing, projects a dearly missed component. That was basically providing a REST API. We also have the requirement often to provide a WebSocketServer, so that WebSocket clients can connect to and get their data from there. This is also provided by the already mentioned QWebSocket module. It's been around for ages, actually, since 5.4. And funny enough, it provides C++ and QML bindings, so you can also do a WebSocket server from QML, if you fancy that. Don't know. This is basically covering the client and the server side. And now to things more visual, rendering web content with Qt. So different use cases. So the most basic use case is to render existing web content within a Qt application. Could be a generic web browser, could be all kinds of walled garden applications, so your set-top box or automotive HMIs providing some content that is provided. It's not free on the web, but provided by a content authoring team or something like this, or all kinds of walled gardens. There's a sprawling market for HTML5 games you can buy for your device. That's also popular. And there are all kinds of authoring and reporting tools that are outputting HTML5. So render them. Qt is offering several solutions for that. There's the Qt Web Engine, which is basically the replacement for the old Qt WebKit. That's a browser component based on the Chromium project, offering QML and C++ APIs. And it's, well, it's kind of a bit complex, but it's also offering you a lot of, you can also do a lot of things with it, but it's a huge component. A bit more lightweight is a QWebView, which is a special case, I think originally envisioned to support mobile use cases where you can't have a Qt Web Engine on your iOS or Android device, where they are wrapping these mobile device native browser components with a Qt API. And nowadays, there's also a fallback for other platforms, which might be Windows, Linux, something like this, which is falling back to a Qt Web Engine on these platforms. So you can, if your application is simple enough, have a unified web component you can use. It's QML only. There's no QWidget for that. This is basically the easiest case to render web content. There are more special cases we've encountered. So basically a web HMI sitting on top of a Qt C++ backend. How is this different from a classic client-server application? You might ask yourself, it's basically the level of integration. You could do the same thing often enough as a classic client-server application, but there are also cases where it makes sense to have a deeper level of integration. Motivations for going this way might be performance, or that you still have valuable business logic you want to reuse, but you want to do the modern thing on the HMI using web technologies. Again, you can use the QWeb engine to host this HMI, and Qt has something called QWebChannel, which is at least the spiritual successor for the old Qt WebKit bridge, which is allowing you to access the representation of Q objects transparently in your browser, and this way to interact with your Q object backend. Special case, but we've encountered it. Another thing we often encounter is it's actually not so much a Qt application of Qt, but rather making use of the work done by Qt. There are not so many freely available pre-integrated browser engines for embedded systems. I know of 2 others, but the Qt Web Engine is a good choice. So basically, the use case is you need a full-screen, no window manager solution for your embedded system. The screenshot you're seeing here is basically we have actually a showcase industrial automation we've implemented in Qt Quick. And this is basically a re-implementation in Angular, which we did for performance comparison on various IMX6 devices. How does the Qt Quick HMI compare to the web-based solution? This can be very nicely done with Qt Web Engine. Keep in mind that system integration can be tricky. So it's a large component that will quite a bit load your firmware with all the dependencies it's pulling in. And it's actually requiring a bit more powerful hardware. So if you need something on cheap hardware, tricky. So this is basically the various ways to render web content with Qt. And now I want to switch sides again. Now I don't want to render web content with Qt, but want to show the output of Qt in a web browser. So this is switching perspectives. So the use case is to have the browser as a remote display. So you might be already committed to write a Qt Quick application for your embedded device. You might have a display, or you don't have a display at all, but you are committed to do it in Qt Quick. And now you have the requirement, yeah, but we want service people shouldn't be forced to install something. They should just go with web browser there, and then it works. One solution to do this is, this is relatively new, around 2 years old. There's a QPA. QPA means Qt Platform Abstraction. Android is implemented by QPA. Windows is implemented by QPA. And there's a special QPA that is outputting WebGL and is basically opening. This was the initial use case for the QHttpServer. So this is basically opening a web server. The web server is delivering a small JavaScript shell. The JavaScript shell is loaded by the browser, connecting back via a WebSocket, and pulling in WebGL rendering commands and sending inputs when the user is clicking on the device. So this can be used to use a web browser as a remote display for your Qt application. Keep in mind, this is Qt Quick only, so you can't do this with QWidget. The nice thing is it's resolution independent. So if you've written your Qt Quick HMI in a device in a resolution independent way, you can resize the browser and it will properly resize. So this is very nice. Latency is critical. So this is not something you would use throughout the internet through several VPNs. This will all be laggy in usage. So the assumption is, I guess, that you are on the factory floor or in the same building, something like this. Depends on the application, how good it works, but latency is really king here. Also to keep in mind, one user at a time. So either you structure your application in a way so the HMI is really a dump viewer on the real application, or you need to be able somehow to start the application several times. Can be tricky. So this is, it's not, for the screenshot here, this industrial HMI use case, there the HMI is very dump. It's really a viewer on the application logic running in a background application connected via OPC UA. That's very much not the web, but this allows us to start just several instances of an HMI, and it doesn't matter so much if the instance is running on an Android tablet, on an iOS tablet, or in a web browser. So this works there very nicely. There's another way to do it. This is basically the official way to do it. There's a, I don't know the English word for Trick 17. There's a special case you can also do. There is also a QPA that is outputting VNC. So you can have a Qt application that is rendering to a VNC server. And you can, that's Trick 17, you can basically set up a WebSocket proxy for VNC and pipe the output of the server into the WebSocket proxy. And there are browser JavaScript, pure JavaScript implementations running in the browser, which you can then use to connect to the proxy, which will show you the output of your Qt application. I've actually encountered this in the wild. I see some critical stares, but I've encountered this. The nice thing is you can use it with QWidget and Qt Quick if you're using the software renderer, but with a modern Qt, this is not really a problem. The bad thing about this solution is that you see it here in the screenshot, that the resolution is fixed. So if I resize the browser, it will not follow the resize. So it's really, it has the size of the virtual remote VNC output. It has the same issue as the WebGL. So you need to start one application per user. So if you have structured your application in a way that you can start several instances of your application, that's fine. If not, it's not a way to go. Also, latency is not so great. It's slightly better than WebGL, so depends how much pain you can take, if you like to use it or not, or how good your networking is. But that's another way to get Qt into the browser. And the third case, for the first two cases, we have used Qt as a remote display. So the Qt application was really C++ compiled to the target platform, and it was remote outputting into the browser. We have another use case which is slightly different, which is also very new. So the task here is to have an application written in Qt that needs to run inside an unmodified web browser. So no shady plugins, no extensions. Again, nothing should be installed. Use cases could be headless devices or our industrial HMI showcase. I need another viewer and the service personnel shouldn't be forced to install something. You could think about in-house software distribution. So you want to allow users to use whatever they want, Linux, Windows, in which version, Mac OS, doesn't matter. It's coming out of the browser. That could be use cases. There is a solution that has nothing to do with Qt per se. It's called WebAssembly. So this is it's portable runtime that all the major browsers meanwhile have implemented, which consists of a bytecode format, various APIs. It's basically the idea the browser as an operating system, so you can really compile your application, your C++ application to WebAssembly, and then run it in the browser in a portable way. That actually works quite nice. Security-wise, this has some limitations. Just because you're running WebAssembly in your browser page doesn't mean that all the security restrictions of a web page do not apply anymore. So that might be an issue we see. Qt is offering something here, Qt for WebAssembly, which is an official platform since 5.13. So you can go and play with this. If you're interested here, under this URL, you can also find a lot of examples pre-compiled Qt. You will know a lot of these examples because they are just examples from the Qt SDK, but they have been compiled for WebAssembly, so you can just go with an unmodified browser there and download the same game and play the same game in your browser. Yay. Our experience with this, the downloads are relatively large. For same game, it's like 20 megabyte-ish, something like this, 20, 30 megabytes. For certain use cases, that might be totally fine. For others, might not be so nice. From a developer perspective, there's keep in mind this is ongoing work. This is very hot, but the link times were not so nice last year. So waiting 10 minutes was a thing to wait for your linker step to finish. And of course, your application still needs to deal with the limitations of the browser. So if you have an application that is making heavy use of file access, of network access, raw TCP sockets, that's a no-go. That's also the reason why I don't have another screenshot of our industrial HMI, because this is using OPC UA with a TCP binary transport. And I just can't recompile it to WebAssembly because the APIs are not there. But still, if you structure your application in a certain way, that's a way to get Qt into the browser. And now it's really in the browser, not just a remote display. So to wrap up, we've looked at Qt from 4 perspectives: API-wise, Qt as a client, Qt as a server. We've looked at rendering web content with Qt and actually getting Qt into the browser. I've talked very fast, so still I had to skip over a lot of topics that are actually interesting and we find in the wild. Things like the wheel keeps turning and turning, so people inventing IDLs again. It's now called ADL, Swagger, Open API, so a better way to structure REST APIs. I've not talked about templating HTML generation, things like this, or even writing a web application in Qt. So if I've missed your use case for Qt and the web, come talk to me either after the talk directly, or you will find me the whole 2 days at the basysKom booth. I'm looking forward to meet you. Questions, please.
Hello. That works better. So if you have any questions, I can hand over the mic so that everybody can hear the question. So just raise the hand and I will come over. No questions? Yes, one.
Talking about the Qt as a server. Yesterday at the customer advice report, there was a talk about the HTTP server that is coming, although not officially. But there was not a word about REST APIs that is missing. Do you have any solution or something that you are using right now that is production ready or almost there?
I assume you would like to have a nice way to generate a REST API, right? One way you could go is if you look into the I've skipped over this. If you look into the Swagger Open API ecosystem, you will find that there are code generators for the Q Network Access Manager to consume REST APIs. To be honest, the code generated is a bit of questionable quality, but it works. And there are also code generators to generate server-side code for REST APIs. It's still early. There are implementations for various open source server-side SDKs. There is no implementation for the basically logically there's not yet an implementation. But if you're really interested in doing this, I would propose to write a generator that is generating REST API code for the QHttpServer. That would be a way forward.
Thank you very much. Any other questions for Frank? Thanks, good Frank. Thank you very much.
Thank you.